Hello everyone, welcome to this video in which we are going to discuss about essential prerequisites for programming. Before diving in, let me introduce myself. My name is Chiranjeevi and I am working as a product engineer at a startup called O Slash. So, what you are looking on the screen right now is an article version of this video. So, if you ever want to revise or revisit this content, you don't need to watch this video. You just need to open this article and you can read it for yourself. I am going to give this link of this article in the description, so do check it out. So most of us start programming without knowing these basic prerequisites. So is it totally necessary to know these before programming? No. We eventually understand these after starting programming. But if you know these beforehand, it will be easier for you to understand the nitty-gritty of programming. So uh, the motive of this video is to provide those prerequisites before starting to programming or to solidify your basic understanding of programming. So the topics which we are going to discuss in this video are uh, what does exactly programming mean in the context of computers. So what does it exactly mean? Like, we think of C, Python, Java, etc. When we hear of programming, but what exactly do they do is what we are going to discuss. Also, we are going to discuss about code, program, software, so and their differences. These things are very subjective and they are different for person to person, but I'm going to give you my perspective regarding these words. And after that, we are going to see the basic architecture of computer. No hardware devices, nothing but the basic architecture which are very necessary in a computing device, not exactly computer but a computer. So let's get started with our first section, which is what does exactly programming mean. So before understanding what programming means, we have to understand answer to a question, which is why computers. Why do we even need computers? Why are we using computers in the first place? So the answer is very simple and very intuitive, which is we want to do some tasks which will take some time, and we want computers to do the same task for us in a very less time, so which will save us time, which is ultimately money. So that's the main reason why we use computers in the first place. So what are we doing with computers now? So if you are a user and there is a computer, you want this computer to do something that you can also do, but it takes some time for you. So now you want to tell this computer to do that work. So for that, what you have to do, you have to tell that computer, so which is nothing but an instruction. So basically, in a nutshell, giving these instructions to the computer to do something that you want is called programming. So basically, in a nutshell, programming is nothing but giving instructions to the computer to do something. So now we know what programming is. So how do you do that? How do you give instructions to computers? Is it very straightforward? You can speak to it? No, you can't speak to it. So what you know is a human language. So what you know is a human language. But what computers know? Computer doesn't know human language. Computer only knows 0 and 1, also known as binary. So here there is a detail which a lot of people, lot of beginners miss. So why computers only understand zeros and ones is a detail that a lot of people miss. So the reason is actually very simple. So basically, computers or any computing device consist of chips, electronic chip. So what does an electronic chip take or give? It only takes electric signals and gives out electric signals. So when you are passing only electric signals, what can you do? Either electricity is on or off. These are the only two signals that we can pass to a chip through electricity. So basically, we consider on as 1 and off as 0. This is the reason why computers can understand only zeros and ones. So now we know what we understand as a human, and we know what computers understand in terms of language. So how do we communicate? We don't know binary. We can't convert every instruction that we want to give to the computer into binary and pass it to it. We can't do that. But computers can't understand our language. So there is something called programming language. So can computers understand programming language? No. So there are two things which will help us in this context: compiler or interpreter, and operating system, OS, operating system. So programming language is something that humans can understand. It is somewhat similar to human language, not entirely but somewhat similar to human language that humans can understand. So what we do is we give instructions in a programming language, and there will be a compiler or interpreter depending on the programming language you are using. If you are using something like C or C++, it will be a compiler. If you are using something like Python, it will be an interpreter. So what these things do is they will send your instruction to operating system by converting it into machine level code. So they convert your programming language code into machine level code and pass it to operating system. And this operating system job is to convert these machine level code instructions into binary so that computers can understand. So this is what that happens under the hood when you are writing a program and giving some instruction to the computer. This is how it works. So now let's come to our second section, which is code versus program versus software. So what do these words mean? So I'm going to give you my perspective. As I said before, this is very subjective and differs from person to person. Mostly it is similar and we use these words interchangeably, but there are some straight meaning to these words, and let me tell you what those. So what does code mean? Code means something that is encoded, so which is not straightforward to understand, and that can be decoded as well. So understand this. You want to do something, you have an idea in your mind, you have to give it to the computer. What you can do is you have to convert your idea to code, and you feed this code to computer, and computer will decode it and performs that idea. So here what's happening is encoding. So you are encoding your idea into some code and you are feeding this code to a computer. So computer now decodes it and performs that idea which you initially had. So that's why a code is something that is encoded and that can be decoded as well. So a code does not need to have a meaning or purpose. A code can be simply anything that is in your mind and you are converting it into some programming language code. It doesn't need to have any purpose, it doesn't need to have any meaning. Let me tell you what I mean by this by showing some code. So now I am on an online compiler. I am using Python language here. It is not nothing specific to Python language, it applies to any programming language. So now I want to print something onto the console, so I'm using print hello. So I had an intention to print something and I have converted that into a line of code here. So I have encoded it. Now this is code. and if I run it, it will run in the console and it gives output hello. This is decoded by the computer, and that's why you are seeing this output here. Now let me do something called a equal to 10. So basically what I'm doing is I'm storing the value 10 in a data store which is named as a. It doesn't have any meaning or purpose. It doesn't even give any output. If you see, it doesn't give any output. The reason is we are not doing anything, but still this is a code. You wanted to store 10. This is what your idea is, and you did that. This is the code, and computer also decoded it, but since there is no output, you can't see it. The computer also decoded it. So what I meant to show here is that a code doesn't need to have any meaning or purpose. It just something that can be anything that is translated from an idea to something that can be written as a programming language code, and that can be decoded by the computer. So that's what I meant by code doesn't have any meaning or purpose. So now that we know what code is, let's start with what program is. So a program is something that starts with an end goal. So it has an end goal. We know while writing a program what we are going to do, what we are trying to achieve with that program. So for this reason, every program has meaning. So since we are starting with an end goal, what we are going to achieve in that program, it has some meaning what we are going to do. So how do we achieve this meaning? It is through code. So we use code to achieve meaning. A simple piece of code doesn't need to have any meaning, but a program which is written through code has a meaning. It has an end goal. We know what exactly we are trying to achieve with that piece of code that we are writing. So that's why a program has meaning, and because it has an end goal. So now let's see what software is. So a software is something that has a purpose. Mostly it solves a user problem. How do we write a software? I mean, how do we generate a software? Through programs. A software is a bunch of programs. So this is basically what a difference between a code, a program, a software. So let me give some examples for this. A code can be anything, from writing a print statement, from storing some small data or something which need not have any meaning or purpose, anything. But a program which is constructed through code, but it starts with an end goal, so it has some meaning. So that's basically program is. So now when it comes to software, a software is a bunch of programs which collectively solves a user problem. So an example for a program can be writing a program to find the shortest distance between 2 points in a Cartesian plane or something like that. So basically when we have a end goal, we'll start with that and we'll achieve a meaning to that program. So a software can be solving any user problem, something like making bill payments, creating a software to make bill payments, or creating a software to transfer money, anything like that. So basically it solves a user problem. It has a purpose. So it is built with a bunch of programs. That's what that's what a basic difference that I see between code, program, and software. So now let's look into the third section of this video, which is basic architecture of computer. So when we hear about architecture of computer, when we are in school, we are taught about keyboard, mouse, monitor, computer, CPU, etc. And when we are in college, we are taught about von Neumann architecture, which are all correct. But what I intended to show you in this video is that a basic architecture that is necessary for any computing device. So there are two pieces which are very necessary to any computing device that is there out in the world, from smartwatches, Alexa, to mobiles, computers, supercomputers. There are two things, those are absolutely necessary, which are CPU and memory. Without these two, there can't be any computing device. There can be any computing device without any display like Alexa, without any speaker, without any keyboard, mouse, but there can't be any computing device without these two. So that's why I have added these two, and I wanted to show these two in this basic architecture of computer section. So how do these align? Basically there are two parts in a memory, two types of memory actually, sorry, two types of memory, which are primary and secondary. These are two types of memory that is there in a computer. So what happens is, there is a CPU and you have your primary memory and you have your secondary memory. So these are connected to CPU. So this is CPU, primary memory and secondary memory. So in very simple terms, this is a basic architecture of a computer. So this is what I wanted to show in basic architecture of computer. I know if this sounds very silly, then yes, it is actually, but this is what actually a basic architecture of computer that is absolutely necessary in any computing device. So now let's get into the section which is how program execution works. So you write program in a Python, C, Java, any language you wish, and how does this program execution works actually? So as we saw in the above section, this is the basic architecture of a computer. So let's just elaborately see what happens here. So you have your secondary memory. So I do this secondary memory very big and this primary memory small very intentionally, because that's how it actually works. So secondary memory is always large in size. Secondary memory is always large in size. It's non-volatile. I'll tell you what non-volatile means. And cheaper when compared to primary memory. So primary memory is usually small in size, volatile in nature, and costlier than secondary memory. So in a general computer, a secondary memory can be thought as a hard disk or a SSD. So they are generally large in size. They are usually 256, minimum of 256 GB to 1 TB, 2 TB in some computers, and they are non-volatile. Let's say you switched off your laptop or computer, the memory that is stored in this secondary memory, SSD or HDD, it will be there. Even if you switch off the electricity, or if the power is off, if the battery is down, the memory won't be erased, and it is cheaper when compared to the primary memory alternatives. So a primary memory in a computer is generally a RAM, random access memory, RAM, HDD or SSD. So a RAM, it is very small in size, generally from 4 GB to 36, 64 GB max in current days. So that is very small when compared to HDD or SSD. Volatile in nature. So the data which is stored in a primary memory device, it will be erased if the power is off or a battery is down and if the device is switched off. So that's why it's volatile, and it's costlier when compared to HDD or an SSD. So when you when you want to store some data, from videos to text files or images, anything, all of them are stored in a secondary storage: files, videos, etc. And also your operating system is also stored in your secondary device itself. And other than this, the things which are stored in a secondary device are all the programs that you write. So whatever programs you write, whatever softwares you have, all of these are initially stored in secondary memory itself. So what happens when you want to run a program? This is CPU. So CPU is the one which runs any program. But how does it do? It is in secondary memory. What happens is, when you are running a program, CPU loads this program into primary memory. Program comes here. So when you go to lower level, there will be something called PC, which is program counter, I believe, and MAR, memory address register, and MDR, something like that. So these are very low level implementations which we don't actually need right now. But what in high level happens is that CPU loads the program which it wants to implement into primary memory, or also called as RAM. So let's say if you have 5 lines of code like this, and these 5 lines are now in primary memory. So CPU comes to the first line, executes this, comes to the second line, executes this, third line executes, and so on. This is what happens. So when we are trying to learn programming and we are doing programming, we discuss a lot about memory. That when we think of recursion, there is something called stack overflow. Where is the stack is there? Stack is a data structure, we all know that, but where the stack is present? It is present in RAM or primary memory. So whenever we talk about space that is going to taken by a program or a memory that is going to be used, all this memory is part of primary memory, because that is where program is loaded into when CPU is executing the program. So when we talk about memory in programming, it is obviously primary memory. So that's what I wanted to tell in this section. So this is how program actually executes. So programs are initially stored in secondary memory, and CPU loads them into primary memory when it's trying to execute them. And when it's there in primary memory, it is executed line by line. Why is it loaded into the primary memory? Why is it both are memories? Why is not taking each line from secondary memory itself? There is a reason for that, which is this interaction, whatever is there between CPU and secondary memory, is slower. It is a two-way interaction. A CPU can take data from secondary memory and it can write data to secondary memory. So it's a two-way interaction. That's why I have kept arrows both sides. And same with primary memory as well. It is two-side interaction. And why CPU uses primary memory to get each line from a program is because this interaction is faster. That is why CPU loads the programs whichever it needs into primary memory first and then executes line by line. So that's what I wanted to show in this section. So that's pretty much for this video. And I was in my BTech first year when I wrote my first program in C language, and I didn't know any of these prerequisites at that time, but I wrote it anyhow. I only knew some hash include, main function, and giving inputs and producing outputs, but I didn't know any of this. But if I knew these before, it would be easier for me and I would have learned programming much faster in a better way. So if you find this video helpful, please like, share it to your friends, and subscribe to my channel. And once again, you can find the link to this article, and it is very good to read after you watch a video or something. If there is a way to revise it, if you write notes, that's pretty good, but if you don't, you can use this article as a notes. So yeah, that's it for this video. Goodbye.